Alright guys, again sorry I'm not here, but here's your lesson for today. We're going deeper with exponential functions. So you need to go ahead and pause the video and copy this page. Again, it's probably not on page 33. Put it on the next blank page. But I'm pretty sure you've already copied some of these. Okay? Oh, they're on my phone. Alright, I'm back. Again, a lot of you have already copied this, so you can, if you haven't, go ahead and pause it. But remember, these were the steps to graph exponential equations. We were going to practice these, but we've had plenty of practice, so I'm not going to worry about it. I gave you this worksheet already, so we're skipping that. All right, you're going to need to copy this down. Types of exponential equations. Use exponential when growth is not constant. Use exponential when you see the words like double, triple, or half, or even a percent sign. Okay, we're going to see some examples. So your basic exponential function or form is going to be y equals abx. Okay. A is going to be your start value. B is going to be rate. Excuse me. Rate of change. Ratio, or pretty much whatever you're multiplying or dividing by. Okay, you'll see some examples in a second. And x typically will be time. Okay, you'll see examples in the packet I gave you. Exponential growth, we're going to use p and then 1 plus r raised to the t power. Okay, examples here. Again, we're using p, so scratch that a out, put p equals. Again, this will be your start value. Principal, kind of like when you put money. Whoops, daisy. Stop this. Principal, kind of like when you make a deposit on a savings account or an investment with a IRA or something like that, stock, whatever. Again, R is going to be rate, or this will be percent written as a decimal. It has to be a decimal. You'll see examples shortly. And X sometimes will be that T up there. Again, typically it's going to be time. Okay? Exponential decay. Again, it's going to be the P. Okay, well, y equals. I think I forgot to put y equals. Let me check. Yep. Should be y equals. There we go. Y equals here, P. This is going to be minus that rate over time. Notice the difference here. Plus for growth, minus for decay. Letters, again, same thing. Again, it should have been a P. It's going to be start value again, or that principal. I'm just going to shorthand this to start value. A principal, again, we have that rate. And sometimes there'll be an X, T, and remember that's time. Okay? Compound interest, this is where you make your money. Again, principal is going to be 1 plus R. N is going to be the number of times compounded. This is an R. And raised to the N over T. So again, P is going to be that principal. R R is going to be that rate. N is going to be compound period. And T is going to be time. Again, sometimes that could be an X. Now you're asking, where do we get this compound period? Well, that's on the next page. Right here. This is what N will stand for. It'll be annual, semi-annual, quarterly, monthly, weekly, daily. Okay, annually is going to be 1 time a year. Semi-annually is going to be 2 times a year. Quarterly, 4 times a year. Monthly, 12. Weekly, we're going to use 52 for this. And daily, 365. Obviously, we're going to ignore the leap year junk for this purpose. Okay? Again, copy all this down in case you don't know. All right, so now you should have your packet in front of you. So, again, here's our notes. Your brother tells you a secret. You see no harm in telling 2 friends. Imagine that. After the second passing of the secret, 4 people know your secret. Your brother, you, and those 2 friends you just told. If each of these friends now tell 2 new people, after the third passing of the secret, 8 people will know. Write an equation to express the passing of the secret. If this pattern of spreading the secret continues, how many people will know the secret after 10 such passings? Okay? So, remember, this is going to be y equals ABX. A is going to be 2, because that's the starting number of people who knew it. If you don't remember, it's you and brother. Okay? B is at the rate of passing. You're telling 2 new people. Okay? 2 people every passing. And when I mean passing, I mean, telling the secret. And again, sorry the handwriting is a little bad. We're using that active inspired. It's not smart note. Okay? So, I think that's all I need. So y equals, substitute, 2 times 2. This x is going to be 10, because we're figuring out the passing of this secret. Okay? So I might even put that here. X is going to be 10, because that's what they told him. The 10th passing of the secret. Guys, plug that in your calculator. Take a minute. You can pause the video right now. All right, here we go. 2,400. Oh, wow, I lost my mind. 2,048 is what you should have. People that know the secret. Okay? Now, for the rest of this packet, you can sit there and pause the video now, try it out, hit play, because I'm about to go over this whole thing with you. It's going to be a long night. All right. So, Alexis was working in a biology lab on her cell project. She started her experiment with 500,000 cells. Every day the cells die by a third. Die. Decreasing. Write an equation to represent how many cells would be left after each day. How many days will Alexis have until there are less than 100 cells left? Okay? So again, this sounds like that YBX. Oh, ABX, excuse me. So, if I was plugging in what I know, A, starting value, that is 500,000. They're dying at a rate, so B is our rate, of a third every day. Put X up there, okay? Now, they want us to know when it's going to be less than 100, okay? So, this is what I'm going to write it like. Let's see, why don't we write it this way? I'm going to put 5,000 over here with that 1/3. Okay. Raised to the x. That needs to be less than 100 cells. We need to figure out when that happens. Okay? Now, if I were you, I would start an XY chart. Okay? Obviously, it's not going to be 0. But if you were to start at 0, the initial, that should be 500,000 because that was the starting. Okay? After 1 day, plug that in. What do we get? And this is me just guessing until I get up to, or get down to 100, okay? So I'm plugging it in as I see it in my calculator. I just love these Casios. I can literally plug in what you see and get the answer. I got 1, 6, 6, 6, 3 more sixes, 0.6, and that's going to be repeating. Excuse me. So go ahead and try it out. Keep working. Ideally, pause the video so you don't see the answer yet. All right, guys, around 7. If you plug in 7 up where x is, you'll get 228-ish. And then if you go to 8, and again, guys, I'm scrolling up, changing these exponents, and then just hitting enter, I get 76. So I'm going to say something like, let's see how I can write this, between 7 to 8 days, Alexis will have less than 100 cells of that bacteria. This is just a rough way to write it, but the answer is going to be 7 to 8. Okay? And if we're counting by whole days, we should say 8. Okay? Number 3. Following table represents how many amount of caffeine in your system each hour after drinking a grande coffee. Write an equation based on the information. Guys, we need to look for patterns. That's what this is all about, is finding these patterns, okay? So from 330 to 165, I think we halved it, okay? 165 to 82, we halved it. Half again. Half again. Guys, the pattern is we're taking a half every time. That is going to be our B. So if we're writing an equation, A, starting value, that should be 330, hence the 0. We talked about it up here. Our rate is a half every hour. So we're going to put an X up there. It says how many hours would it take to have less than 1 milligram caffeine left in your system? Guys, again, this is that idea that we did just a second ago. You're going to have to make a T-chart and sit there and hash out the problem, okay? To be less than 1. Well, you know what? You don't make a new one. You can come right over here and continue, okay? So, try 5, try 6. I'm not going to do it. I want you to, so pause the video. Okay, we're back. Guys, you should be about 8 to 9 here, okay? Between 8 and 9, you'll have less than 1 gram of caffeine. So let me just go ahead and jot the answer down. Again, I'm punching it in my calculator. I don't know if I can punch in my calculator correctly. There we go. Raised to the power of 8. So look, that 8 is going to be 1.28. That's not less than 1. So then I go back and hit 9. And then you're going to have 0.64. And that is less than 1. So I would argue, 8 to 9 hours before you have less than 1 milligram of caffeine. Man, it's hard to write with this program. Okay, something like that. The goal is between 8 and 9. Now, I could show you a shortcut to figure out what x is, but that's junior level math, and we're not ready for that. So just use a t-chart, hash out the numbers until you get there. Okay? Let's see. Number 4, Sally. Sally has, oopsie daisy, got to change the slide. Sally has a leaking faucet in her bathroom. When she first noticed the leak, there was a puddle that was 2 inches in diameter. Each hour, the diameter triple in size. If Sally doesn't do anything to stop the leak, how large will the puddle be after 10 hours? Okay? Each hour triples. So, y, initial value was 2. It's tripling, so that's 3 raised to the x. They want to know after 10 hours, so I'm going to replace that x with a 10. Plug it in my calculator, and we get too many ones. That's what we get, too many ones. We should get 118,098 inches. Okay, that's diameter. That's pretty big. Let's talk about feet. I'm going to divide this by 12 inches. Okay, this will convert it to feet, and we will get 9,841.5 feet. Guys, that is larger than my trailer or any house whatsoever. Your house would flood. Sally needs to fix this faucet now, right now, or she will drown. That is a lot of water. Math rocks. Let's keep going. Growth. Pull this paper out. It should be in front of you. I gotta pull mine out. Let's see. There we go. Guys, you're just answering the questions. You can fly through this with ease. Okay? It's growth. For answering if it's growth or decay. It's growth because this number is greater than 1. Okay? What is the rate of growth or decay? Guys, that's going to be 75%. Now you're asking, well, how'd you come up with 75? Well, remember, this equation comes from this formula. They're adding 1 to a decimal. So we want this 0.75 because that's the rate. But remember, you got to convert it. Okay, 0.75, change it back to a percent. You got to carry the decimal to the right. 75%. Okay? Now I should be able to convert decimal to percents. It's easy. What is the initial value? Guys, our notes told us that's P. 15's in that P spot. The answer is 15. Evaluate for x equals 4. You just plug this in. Plug it in your calculator. You should get about 140.68, give or take. Okay? Pause the video. Why don't you go ahead and try at least 1 through 3, or 2 through 3, excuse me. All right, we're back. Real quickly, just to check your work, you should have a growth here because it's greater than 1. You should have 23%. Essentially, just dropping the 1 and carrying the decimal over. Again, to show you if you don't remember, carry the decimal over to get 23%. Initial value should have had 25. And if you evaluate 2, remember it goes where the x is. Plug it in your calculator, you should get about 37 point, I don't know, 82-ish. Okay, the next one, I'm just going to put the answers. Should have had growth. Now this one, be careful, 0.06, carry it over is just 6%. Okay, don't be fooled. 154 is the initial, and if you plugged it in, you would have got 231.56. Again, you're just plugging the 7 in for the x. Bada boom. Alright, tuition. So this is for us college-bound kids. Tuition as a private college, no, the tuition at a private college was $15,000. Yikes. The tuition was about 7.2% annual increase. Write an exponential equation describing the situation. Guys, easy peasy. First, convert this to a decimal. 7.2, you're going to the left. 1, 2. Put the 0 there. So, we should get 15,000. That's the initial value. 1.072 raised to the x. Remember, this number came from 1 plus 0.072. Okay? The formula. When you add them, you just pretty much tag on the 1. Okay? Tuition B after 5 years, you're just plugging that 5 in for x, so 15,000. 1.072 raised to the 5th year. You should get something on the lines of 21,235.63 cents. Guys, this should make sense because it's increasing, it's growing, it's higher than 15,000, so we're doing the right thing. If it was less than 15,000 after they just said it's supposed to be increasing, we messed up. Okay? Self-check yourself. We'll try to fly through these a little quicker. So, a vintage radio was purchased in Grandma Schmitty in 1945 for $16. You have the radio. Know what it's worth. You have the something's wrong with that sentence. It's worth. Each year, the radio's value is increased by 1.4%. Write an exponential equation describing the situation. Guys, it's increasing, so you should have y equals initial value 1 plus this as a decimal, so 0.014, so it should be 1.014 raised to the x. Okay? So, what will the radio be worth in 2020? Guys, you got to do some math. 2020 minus that 1945 is going to get you 75. 75 is going to go where the x is. So 16, 1.014 raised to the 75th power, and we're going to get $45.40 cents. Tongue twister. All right. Ben made $2,000 last summer mowing lawns. He wants to continue this business in the following years. He hopes to have a profit increase of 10%. All right, exponential equation describing the situation. Again, I'm just going to go straight to the answer. Initial value should be 2,000. You're growing, so it should be 1.10. You're just adding it. Remember, follow the formula. And what would it be after 7 years? You plug that in for x. So 2,000 times the 1.10 raised to the 7th power should be about 3,897.43 cents ish. And again, if I messed up my calculations, my fault. But this setup is right. Okay. Let's keep going. Marcus collects baseball cards. He paid $250 for Babe Ruth collectors. 2008. each year the card's value increases again by 3%. So, equation here, y equals 250 because of the initial value. It's growing, so 1.03 raised to the x. Again, change that 3%, you got to carry the decimal over. Okay? Plug in the 10 years, so 250, 1.03 raised to 10 years equals 335.98 cents. Almost done. Excuse me. Population of an ant farm increases at a rate of 20.6% per day. If we start off with 56 ants, can you find the formula that models this rate of growth? Yep. Y, don't know why that menu keeps popping up. Y equals 56 because that's our starting value. It's increasing at 20.6, so if you carry the decimal over, tag on the 1, should be 1.206 raised to the x. How many will there be at the farm at the end of day 4? So you're just simply plugging in that 4 where the x is. And we get 118.46. You can't have pieces of an ant. I don't know. We'll just say 118. Okay? C. Will there be more than 1,000 ants after a week? About how many days does it take to populate more than 5,000 ants? Remember, a week is 7 days. Okay? So simply said, you're going to plug in 7 for where the x is. So I'm going to do that over here. 56.206 raised to the 7. You're going to get about 207.79 ants. But as you know, we got to round that skeeter to about, we'll round up this time, 208 ants after a week. Okay. Let's see. Now, guys, this next part, just like that XY chart, you're just going to plug in numbers, okay? So go ahead and pause the video. Instead of 7, do 8, 9, 10, etc., etc. Then you're going to get to a point where you get to 24 days. Plug in 24 days to X, and you're going to get 5,017.9, or if we round that again, 5,018 ants. Okay? Now, we want 24, you know. I mean, if you sat there and plugged in 25, you're going to overshoot it. We want the day they reach 5,000 amps. So that's going to be 24. Okay? Number 9, you just won the lotto. You have 2 options. You can take a full $5 million now, or they'll pay you $5,000 this year, and then double the amount they pay you every year for 10 years, which will get you the most money. Guys, this is a con artist's dream. So do the math so you can figure out which one is better. Right now, they're getting $5 million in one shot. Let's see what this exponential growth is going to do to us. 5,000. They said they double it every year for 10 years. Do the math. Oh, no, these should be equal signs. Do the math. You're going to get $5,120,000. Last I checked, that's $120,000 extra. What do you think I'm going to do? The double option. That's right. That's like another Ferrari, or at least a Viper sitting in my garage. What? Let's keep going. Alright, I don't think you have this page. Let me check what page you got here. We took care of growth. Now we need to take care of decay. Ooh, we're almost done. Okay, let's find the decay page. Is this it? Yep. Alright guys, last page. Well, last front and back page. Of course, I gotta find in my note. Oh, speak of the devil. Guys, same thing, but notice we're subtracting. Okay? Keep this in mind. So, what is the decay factor? The factor here is going to be 0.7. Okay? They're going to ask you what's the rate of decay. How did they get to that 0.7? Well, they must have subtracted something. Look at here. I'm looking at this parentheses part. 1 minus r equals that 0.7. Okay? So I would solve to get it. Or a quick way to do it is to just switch these guys around. So what's 1 minus 0.7? 0.3. Write that as a percent, so we need to move the decimal over, and we get 30%. Okay? This is the rate. This is that decay factor, because after you take that 30 and plug it in, 1 minus that 0.3 is going to get you that 0.70. You got to work backwards with these. What is the initial value? Well, that's the same as ever, 24, where the P is. Evaluate for 6. Guys, you just plug it in. 6 on top. That equals, I got about 2.82. Okay? Again, pause the video if you want to try to work this out on your own. And then hit play again, and I'll give you the answers. And then I am going to go home because it is 8:39, and we are like 30 minutes into this video. Alright, so, given the equation, again, factor 0.23, okay? If I subtract that from 1, we get 0.77, or 77% for the rate. Initial value is 8. Plug this 4 into x. Holy moly, gotta put parentheses right here. Plug the 4 in, and we get 0.02-ish. Alright, again, decay factor is 94. The rate, remember, 1 minus the 0.94, and we get oopsie days, let me don't put that there. Let me make sure we're getting somewhere here. 0.6, but actually that's 0.06. 0.06. Carry the decimal, 6%. Sorry about that. Initial value, again, is 104. It's where the P is. And evaluate for 7. So 104.94 raised to the 7, and we get 6. Oh my goodness. Oh, forget it. Let me just erase all this. 67.44. Oh, something I forgot to mention earlier. Guys, you know it's decay if this factor here is less than 1. Okay? Growth was greater than 1. Decay is going to be less than 1. The rate of the parentheses, or not the parentheses, what's in parentheses is less than 1, it's decay. If it's greater than 1, it's growth. Get that down now. Excuse me. Alright, number 4, Mises. The mice population is 25,000 in 2000 and is decreasing by 20% each year. So our equation, again, we're just plugging stuff in. 25,000, 0.80 raised to the x. That 0.8 came from 1 minus 0.2. That's where that 0.80 came from, okay? And it's understood there's like a 0 here, okay? So, that gave us that. Says, what would the mice population be after 3 years? You just plug that 3 in. So, 25,000, 0.8, raised to, well, not raised to the x, we're raising it to the 3rd power. Let me make that look just a little better. Raised to the 3rd power, and we get 12,800-ish Mises. Okay? We'll put a little box around it. Boom. In 2010, I bought a car for $28,000. As soon as I drove it off the lot, the value started to depreciate. Same thing as decreasing, 10% each year. Okay? So remember, 10%, 1 minus 0.10, that's going to be 0.90 for my factor. So y equals initial value, 0.9 raised to the x. Says, what will the car be worth in 2020? Guys, that's 10 years away, according to the problem. So I'm going to plug 10 in for that value. So 28,000, 0.9 raised to the 10 is going to be about 9762.996, but you know, I think that's going to round. So we'll just round it to $9,763. And this, truth be told, is about the truth with some models. In 10 years, they'll be less than half of what they're worth. Okay? That's why you got to take care of your cars. All right, and I think Honda has the highest resale value as of right now. And maybe Toyota too, but that's all I know about cars. Well, I know more about cars. But anyway, we'll get into that later. Number 5, 6. Wait a minute. Was that 5? Okay, it was. I saw the 4 and I was like, wait a minute. All right, number 6. We purchased a stereo system for $830. The value of the stereo decreases 13% each year. So remember, 1 minus 0.13. It's going to be 0.87. That's what I plug into my problem. So y equals 830 parentheses. I keep getting those two words mixed up. Raised to the x. Plug that 3 in for years. So 830.87 raised to 3 is going to be about I think it's $546.56. And remember, it's decreasing, so if my initial value was 830, my answer had better be less than that. And number 7, number of industrial jobs in Cobb County is decreasing by 8.5% each year. If there's 12,000 industrial jobs in Cobb County this year, so let's write an equation. Y equals initial value, 12,000. Remember, this is going to be 0.915 raised to the x. Remember, 1 minus 0.085. Don't forget to carry the decimal over correctly. After 8 years, so 12,000, parentheses, 0.915 raised to 8, and we get about 5,895,898. You can't have pieces of jobs, so we'll just round it to 5,896. It's decreasing, but guys, look at that. That is less than half the jobs are gone in Cobb County. Okay? And put jobs. Label this stuff correctly. Alright, and the last problem, home stretch. For Christmas, you get an iPhone 5, or 8, or 10, whatever number we're at right now. It's worth $300. Every month, the value decreases by 3.8% with all the new products coming out. So we will have y equals $300, which I don't even think is $300 now that I think about it. Remember, 1 minus 0.038, so we can get 0.962. So 0.962, close parentheses, raised to the x. Okay, we got 3 years. Guys, 3 years is not the same thing as every month. So in 3, we got to multiply that by 12. to get months, which is 36 months. That's what we're going to plug in for x. So 300 times 0.962 raised to the 36th power, and we get about $267.08. Okay, guys, I think that covers all your worksheets there. And you can start working on USA test prep so your grade can increase. Y'all have a wonderful day, great weekend. Buenos dias.